on that is that with a lot of systems out right now, where in research, there's been a lot of development in standardization of images. So the standardization of actually dermatological photos, clinical images, using different approaches such as specular reduction, illumination correction, as well as there are different ways that you can actually make, I guess, clinical images look more like dermoscopy. This allows you to then use these methods to grow your data set so that your clinical images, at the very least, can be used as part of the training or pre-training process before you even fine-tuning for dermoscopy. So I could really see essentially the ways that we could actually improve and reduce the actual quality variability using a combination of best practices for dermatologists as well as image processing approaches for removing a lot of the anomalies that are, or inconsistencies with dermatological clinical images and making them more consistent like dermoscopy, and then being able to combine them together from a learning perspective.
Thank you. Does anyone have questions about this particular answer or question? We have about a minute.
I'm curious about, again, hyperspectral images, because I think this is a really exciting frontier. If we could have a critical amount of hyperspectral images, this could completely change how we do research, at least on this topic. And I'm curious if those cost issues and approval issues also apply to research, and if we could, for example, how do you see we moving ahead to, at least in our research community, having access to those hyperspectral images?
That's a very good question. And again, it all boils down to cost. So at least just speaking, I can't speak for others, but in our lab, we actually produced a portable system for hyperspectral imaging for dermoscopy specifically. So you're able to capture both dermoscopy as well as hyperspectral data at the same time and combine it into a virtual spectral cube. And we're able to build it to around this size at maybe $1,000, which isn't too bad, plugs into your USB. The issue there is that while we can produce such systems, in order for us to get these systems in the hands of even researchers, let alone clinicians, there's a very long approval process. And that's actually what's delaying the issues. Like the system, we've designed it, we've tested it, it works. You can capture as many images as you want. That's not the problem. The problem is that to go through all the entire clinical approval process and then go into mass production, even for the clinical community, is a very long process. So we started that process, but when it gets to the hands of researchers such as yourself, that's I don't know exactly how long that's going to take, just to be very honest. And it's not from the lack of effort.
Dr. Grana, did you have a question to ask? Please, Amir.
Yes, sorry. So on the clinical images side, I'd like to ask one thing I didn't see, I don't see often being commented, is what instead is done in usual practice in dermoscopy, is looking at the same lesion on the clinical side, and then looking at the dermoscopy images, or even applying more, getting more images, more than one capture of the same image, different zooming. So usually doctors in Modena do that thing. So why this is not usually, we don't have data sets with the multiple modalities images for the same lesion? Any comments?
Yeah, I could comment on that, and it's just again, this is an anecdotal answer from talking to dermatologists. I think, man, you probably tell, they're very time constrained. They're not going to spend the effort doing it. Right now, we're designing a system. So with the system that we design, it automatically captures through all the modalities, all different zooms, and so on. It's an automated process. But in your standard, let's say, smartphone camera that you, let's say, have on hand, or any other cameras that they might have, it's a very manual process. And for them to actually go through the effort of capturing many different images in a very stable, reliable manner at different zooms, and trying to account for lighting. I've seen them try to do that. It's a very painstaking process. And so unless there's a strong motivation from the clinical side, especially when they have a huge log of patients to see, it's just very hard to capture. And I think this is not just for dermoscopy, just for any clinical imaging. It's not that, let's say, the radiologists, technicians, or clinicians or people taking the images are not trying to put in the extra effort. It's just that they have so much things to do in the clinical pipeline that they just cannot afford to do it. And so that's actually kind of the struggles where getting data from clinician outside of ethics, which is another very long process, is getting them to go through the process of doing it is quite difficult.
Thank you very much.
Andrew, do we have time just for a quick comment? And I totally agree with Alexander's comments and answers and the question Dr. Gunn asked. I think there's a really good question here, and the challenge for the students, for our research teams, to work on automating images. Like, imaging process is a labor-intensive part of dermatology, dermoscopy, and documentation and digitization. So how we can automate imaging so it's less time for doctors, it's quality, it's repeatable, it's standardized as much as possible. I have some ideas. We also have, I'm happy to share here, for example, about automating imaging. So we have a little mini drone that we are programming for automating exams in 2 minutes. So it can take several images, different zooms, different orientations, different lightings. It is the vision is really to automate and standardize that. But it's not just a drone, even for our users, for our doctors, for our consumers to take good photos. We can have definitely algorithms and computer tools, software tools to help it. And I would ask, like, even if this is one of the next few ISEC challenges or one of the competitions, it's a really big problem. And if we can solve it, it's definitely going to help with the advances on the algorithms and data side as well.
Completely agree. Essentially, it's about standardization of the process, but also trying to automate a lot of the standardized process itself.
Yeah.
Thank you. So the next question is for Dr. Shandel. So in the clinical practice, we monitor lesions, right, over time. How can we do this kind of monitoring of the evolution for skin lesion classification? For example, do we do at the level of individual lesions, or do we do in the setting of whole body photography?
Well, so I think the answer will be both. So right now, hardware vendors are creating machines that can do mass total body imaging, basically, because it's pretty fast and it covers the whole body area. And what I can imagine happening is training networks that can evaluate change of a single lesion, but not just in the context of the single lesion, but also in the context of the full patient. And this is maybe also one of the future problems in that area, because I think Peter Sawyer is doing a lot of work on that in Australia, because he has a lot of machines doing this, is that we start to see, or maybe let's go back a step. Right now we do digital dermatoscopy on single images. We put the camera on there and monitor it. And we found ways to evaluate change in these lesions. And it's not a perfect process, but we can now detect change that is okay and change that is probably malignant and should trigger a biopsy. Now, this was selected lesions. So we have a selection bias inherent in this system. Now, if you start to have machines that can photograph everything, and in that case, probably also lower risk patients and younger patients, you certainly suddenly start to see that everything is changing, because moles are not a static, it's not a static thing in humans. It's probably more a coming and going. And in the early decades, it's more of a coming, and then in later decades, it's more of a going. So everything is constantly changing. And I think this will be a very, very difficult thing to analyze in the future. What of these changes are still okay and which are not? Because, and this is the problem of scalability, if you now have the possibility to have these machines on a wide scale, or probably even population scale, even very, very small percentages or fractions of percentages of false positives are catastrophic. If you have, let's take Austria, a very small country. If you have 8 million people and maybe just 1% false positives too much, this is overloading the healthcare system. So as these things become more powerful and have the opportunity to help find these problematic fast-growing melanomas, we also need to take care of that we don't do errors on these population scale things. And maybe just to come back to your answer. So for example, if you have a pregnant woman, her lesions will change overall more. So you shouldn't just look at one lesion that is changing, but need to evaluate the change in context to all the others that are also changing. This is what we do in practice, of course, already. But if you want to automate this, this knowledge needs to go into your system.
Can these TVP machines image at the level of dermoscopy, or they are all clinical type?
So the way this is going right now is cross-polarized clinical imaging at high resolution, which is it's guiding towards the quality of low resolution dermatoscopy, I would say. And I assume that this will maybe be enough quality for most people. So it's not really just clinical, and it's not high resolution dermatoscopy. It's kind of an in-between. There's a lot of technical problems with focus of depth, but it's more of an in-between, yeah.
Okay. We have time for a quick question. Anybody wants to ask anything about monitoring?
If not, maybe I can comment something from before from the clinical images as a clinician. I know you have your hopes that physicians can make good photographs if just having an iPhone. My experience says, unfortunately, no. So these things are blurred, they're out of focus, they're not centered, they're somewhere else, they're not standardized. There is a standardized process. I think it's published in JAAD. It's called the Blue Journal. And so theoretically, people could adhere to these things, but it's just very hard for them to do. The reasons may differ, but it's just very hard. And from the problem with clinical images for automated skin cancer detection is twofold. So the first one is for pigmented skin lesions or for melanoma. Clinical images are inferior to dermatoscopy. It's just the way it is. This is why with clinical algorithms, you will never get to sufficient accuracy. The second thing is non-melanoma skin cancer or keratinocyte cancer. And if I've played around with clinical images for automated detection, and the thing is, they often happen on sun-damaged skin. So you'll have noses and ears and eyes within the images. And these things are super good clues for an algorithm to say, well, if I see a nose, well, it's a keratinocyte cancer. So, and of course, people don't photograph normal noses in clinics. So you don't have the counterbalance of non-problematic areas. So this is a hard problem. I don't have a good solution for it, but this is something to think about when doing this. And I think it's many years ago now. I heard from Andrea Esteve, this is the problem they had with their algorithm. When they put it into a smartphone, they recognized that certain diseases are photographed in certain ways, like genodermatosis, probably with full body image. And so suddenly, if you come into a position where a certain disease is photographed in a certain way, your algorithm will pick that up and go into that diagnosis. So this is why the non-controllable imaging of clinical images is a really hard problem, in my view.
Thank you. We need to move on to the next question. Again, for Dr. Schandl, what are the significant problems with existing public skin disease image databases, like ISIC or the other newer ones?
Well, the obvious one, and we have heard it many times today, is skin of color. I may add a different thought to it, which maybe pertains to dermatoscopic images, but also to the Fitzpatrick thing. So you find that there is a bias that there's probably too little pigmented skin for certain diseases. But the thing is, some diagnosis is just rarer in pigmented skin and the other way around. So what I'm saying is the difference between a bias and true pretest probability, it's difficult. I mean, for every little thing, you have to check back with a physician who knows what he or she is talking about, be it either on oncology or inflammatory skin diseases, whether this bias that you found is a true problem as a bias, or it's just reflecting something that is real in the world out there. Like, for example, melanoma is rare in darker skin types. On the other hand, keloids are more common in darker skin types. So it's an interplay, and it's unfortunately, like everything in life, it's difficult. And the thing is, should we now then not collect any pigmented skin in these data sets? And the answer is a clear no, because we need to explicitly find what is a bias and what is not. There's no laziness that it should be allowed here. We just need to do it. And we need to, it's also what we are doing is get into contact with centers that have more pigmented skin than we have, and try to enable them to also produce data sets and publish data sets that we probably can't. Okay. So this is maybe the most pressing thing. And the second thing, which I think for now is not a problem of the ISIC archive, but if, for example, these clinical data sets come into play, I think the codification of diagnosis needs to adhere or be interoperable with something that is standardized. It probably doesn't need to be SNOMED clinical terms, but that's would of course be ideal. But maybe ICD-11 or some of these things. The ISIC is working on a reasonable subset of diagnosis. That's as much as I can tell you for these things. And then there's also something, and I think Google made it pretty fancy in their clinical paper. Maybe there's not one true diagnosis. Sometimes you have evaluations of a clinical image, and it's especially in clinical images, that you have a range of differential diagnoses that are reasonable given this clinical picture. And this, most of you probably don't know, but this is real life. If I see a patient, I don't always have, this is the diagnosis. Of course, sometimes it's that way, but the situations where I would need support or someone else would need support is you need to have a range of differential diagnoses which you can work up. And right now in public databases, this is not reflected. And also, for example, Matt, you said there are many mistakes in the Fitzpatrick data set. And I took the time to look through it. And yeah, it's true. There is an acne image from a sole. So this cannot happen, of course. Now, the thing is, how do we handle this? I've created data sets myself, and this is hard. You can never have a perfect data set with perfect labels out there. So maybe we need to embrace the versioning of data sets also in academia. Maybe we need this. So now this is Fitzpatrick 17K, and now you get different people labeling it and have multiple labels attached to these images. Or maybe remove images if you say, well, they're not good enough, they're wrong. So maybe this is a thought on how we will handle this as a community. How do we want data sets to behave? And maybe there needs to be continuous learning, not just for machines, but also for data sets.
Well,
so these are my thoughts.
Thank you very much. We're gonna be adaptive and change our time allotment to 3 minutes per question from now on.
I'm sorry.
Next question, yeah, no problem. Yeah, you of course you have very good experience in both domains, so you have more to say, naturally. Katarina will ask the next question, next set of questions.
Okay, so actually the next question is also for Dr. Shandul. And something that we always discuss is this development of the methods and so on, but most of the times we don't discuss our end users. and one of them are dermatologists. And several of the dermatologists are still unaware of the benefits that AI can bring to them. So what kind of activities can we do? So what kind of actions can we do as a technical committee to engage more these dermatologists? Like, for example, in meetings like AAD, EADV, the World Congress of Dermatology.
So I think clinicians are already waiting for stuff to happen, to be honest. And now, what is needed to get this into practice now, that all these things that we have? And maybe one thought here is to get you encouraged to maybe do your own stuff. In our Nature Medicine paper, on purpose, we used a small network. It was just a ResNet 34, and it was just trained on 10,000 images. And even with this, there was no ensembling or anything fancy. And even with this very small thing, with very, very little data, we measured a positive effect if collaborating with physicians. So my thought is, if you want to put something out there that is trying to work with physicians, don't be shy, and maybe just try to go out there and try to get approval for it as a medical device. Of course, it's hard and it's expensive and it's long, but if this is not happening, nothing's going to happen. This is the big border now. We know this can help people, and we know how to do it, or at least in some cases know how to do it. But now it's probably the company's time to try to get this out there. It doesn't need to be perfect. It doesn't need to solve everything. In most situations, it's probably inexperienced people just trying to say, well, should I biopsy this pigmented skin lesion? And if you can just answer this question, or help the physician answer this question in a more reliable fashion, you're good. You don't need to cover every single diagnosis out there. Maybe what we have is already good enough. I don't know if that answers the question now.
Actually, we still have some time around this question, and I'll go over a follow-up. So, like you mentioned, we have regulations, right? And regulations impose constraints. And one of the constraints, for example, will be the performance. So what will be a good performance for one of these methods to convince someone to buy it and to use it at the clinic? Because that's something that's really hard to define.
So the FDA, and I think also the European Commission, when regarding skin cancer diagnosis, they expect exceedingly high values that I think are sometimes unrealistic. Also for physicians, for real life physicians, giving single images. So, but this is probably not the goal if you want to use this in the hands of a physician. Maybe the target metric should be not the absolute accuracy for a single image, but giving probably a prospective trial, can you improve the biopsy rate, or can you improve recognition, or can you reduce biopsy rates in this study? This is probably a more appropriate metric. But if you want to use something in the hands of laypersons, the whole story changes. And this is also why I think things will become very, very difficult. And it says the same thing as I said before. If you deploy something to millions or even billions of people, the regulatory agencies rightfully demand an extremely high accuracy that is probably even unrealistic, because you don't want to hurt healthcare systems. Because there is always not everything that is reasonable does help people. There is a study from Australia where they had an intervention to just make male persons above 50 aware of skin cancer. That's it. That's it. It's just skin cancer awareness campaign in a high-risk population. And the quality adjusted life years in that intervention group was worse than for the non-intervention group. So even for something that you will, in your mind, you would think, this is obviously the right thing to do. There's no discussion about it. Even then, it might not provide benefit to the whole population group you're referring to. So this is why I try to urge more physician-guided interventions than layperson-guided interventions, because they have a high leverage, which can have a huge benefit, but also, on the other hand, a high detrimental effect to people. So you need to be very conscious about this.
Okay, thank you. I'll move to the next question, and this one goes for Dr. Sadeghi. So we have been talking here about diagnosis of skin cancer, but dermatology goes beyond skin cancer. So for example, there are inflammatory diseases. So how close are we to developing a tool that is able to cover a lot of diseases that goes actually beyond skin cancer, something that is commercial?
I think it's a great question, and also I've answered this several times recently when it comes to general dermatology. There are several challenges when it comes to general dermatology. I think the intended use is important, the target user is important, and also the fact that we're talking about hundreds of different classes in general dermatology. We're not just talking about like 7 classes in dermoscopy, right? So it's much more complex. But I'm not saying it's not possible. I think it's just designing it in a way that, again, it is about that communication with your user, setting the expectations, educating your user about that. And it is then coming to the intended user who's going to be using this. So if you have that and you're talking about professionals who's going to need the general dermatology application. So there are, I know, several projects recently published work in this domain. We are also working on that. But I think it's a little bit far from dermoscopy AI commercialization and tools that can help in real life settings. Again, explainable tools, educational tools, tools that can help with patient monitoring. Those are different than diagnostic tools, right? So I think general dermatology, just because of that problem, and also the difficulty of standardization in imaging. But it doesn't mean that we don't have or we cannot have algorithms for specific diseases. We have several projects on specific, for example, just dermatitis or psoriasis or very specific setting that you have a very well-defined objective and you can evaluate the result. But what is difficult is that you have many diseases that you don't have a good representation in your database from those. And you have this tool that is marketed or designed to help with general dermatology without specifying what is not there and what should not be there. So this is, I think, all about that design, really. It's not the feature. It's not like the accuracy of the system in diagnosing skin problems, like what are those skin problems, but we are expecting the system to perform. So for those reasons, I think there will be some challenges with general dermatology, but I have seen very good move in this direction. And yeah, it's difficult, as Philip said, it's really, really difficult. It's really difficult when we talk about diseases in different skin colors. They represent totally differently in different stages of the same disease, right? Like you have pemphigus, just look at the lifetime of this disease, and like these are all pemphigus, and it's the same patient, the same lesion. It means we need much more data from all these different problems to be able to confidently say that our system is capable of detecting this disease and like during disease life or stage, different skin colors, different conditions. So anyway, I think there is a good move in that direction, and it's a really good one. I think we will be able to serve millions of patients because it's more common than just a skin cancer. But I have not seen a commercial system that has checked those boxes for an approved diagnostic tool. However, there are many amazing programs being developed for educational purposes or different applications. Like it's, yeah, it's not direct diagnosis, but it's helping with educating.
Yeah, and actually, since you mentioned the performance and the explainability, this brings me to my next question. Actually, that is, so for example, in Europe, we have these very strict regulations, and one of them is that these systems have to be explainable somehow. So you mentioned that on your talk. We also saw that on a couple of papers here at the workshop. How can we improve the explainability of these models? So what will be the next steps?
I think it's a general really concept that needs to be developed more, and we don't have really best practices in this domain yet. We don't have guidelines to follow. We don't have, even like if FDA or other regulatory agencies want to see all these develop, but they don't have really guidelines to say how you should do this as companies. But we are all doing our best and developing these best practices, for future. One of the important, I believe, points for explainability is communicating with the user what are the true capabilities of the system and where are the edge cases. And one of them is actually your database. Do we tell our doctors that, look, we don't have these 500 diseases in the database, we only have 140, right? Do we tell them? Do we tell them that this is the distribution in each class? That's also important. Do we tell them that our analysis shows like almost equal distribution for these different classes, but we are forcing the algorithm to match it to the top one, or we have a cutoff like to calculate that. So these are all part of those communication with the doctor to make sure that they don't see this as a black box and they are just accepting it because they are not confident and they rely on the machine when the machine is also confused. Right? How we communicate with the doctors. So I see really AI and explainability as a tool, as an engine that will have several different visualizations, data analysis, communications, and UX and UI is really important. When we talk about AI, we think about an app and a result. But again, that is not possible to work in real life settings. That is not how our doctors work, right? They may do more research, they may talk to their colleague, they may talk to patient more and just ask more questions. But when you have a black box answer in front of them, they say, oh, the computer knows, and if I'm not taking action now, I will be liable. So I better just, follow what the machine says without understanding all the limitations behind it. So I think it's important for explainability to cover that visualization and make sure, okay, it's understandable. Finding similar images and all those great things. Also communicate with them what are the edge cases, what are the potential failures for the system. And just to be fair to the machine, I talked about fairness to AI, and it was, I think, well received in one of my talks that we need to be fair to the machine. We have not trained the machine on these cases. We cannot expect the machine to be good at it, right? So that is about that fairness, which means we need to communicate with our users as well.
It's okay, I just add a point to what Miriam's saying. I think those are really great points. One thing I would just want to add from an explainability perspective is that when it comes to designing explainability systems, they do a lot for different clinical systems, medical imaging, and so on and so forth, including for dermatology, is that it is very important to provide quantitative justification to your explanation. It's about moving beyond just a heat map of, okay, this might be interesting, but actually identifying an exact critical factor and explaining why that critical factor. And we've built such systems, and when we show that to dermatologists, radiologists, and other clinicians, it changes the perspective from, I don't know what's going on, to, okay, it's providing me with justification as a potential second opinion. And one last thing we're going to add is, especially for designers, a lot of times when we're doing models, we don't look at the data. It's just a fact. A lot of times look at top 1, top 5, precision, recall, sensitivity, and so on and so forth. I've talked to many grad students, especially, who've never looked at the data sets at all. And that's a definitely no-no. But explainability is actually a great way, because what we've been really found is that with explainability-driven types of data audit, you actually can figure out when your model is behaving incorrectly or improperly. We've seen situations where lesions are determined as cancer by never ever looking at the lesion itself. It looked at text, it looked at the ruler, it looked at something. You might have really great 90, 100% sensitivity specificity, but if your system is looking at everything but the lesion, then that's a fundamental problem. So just for those who are actually building these kind of systems, it's very important to not just use explainability for clinicians to understand, but also using it so that you could design better systems.
I want to make a comment about that last intervention, because I think that one potential problem that we have on those explainability things is because they are always appearance based. Even when we go back the medicine, we always talk about ABCD, ABCDE, etc., patterns, globules, etc. And ultimately, the explanation is biological. There is some biological phenomenon that happens and that causes the lesion. And I think that what I would love to be able to do is to give an explanation that, okay, I'm looking at this macroscopic planar image, but I am able to hallucinate everything that biologically is happening underneath. And okay, this is a melanoma because I know that the melanocytes are proliferating. That's your explanation. I am able to prove you using the image that the melanocytes are proliferating much faster than they should. And I think that the successful explanation models that we have today are able to have the generative space with these features, and the features make sense really, not in terms of appearance, but in terms of explanations access that are true explanations for the task.
Eduardo, maybe if you're interested, so we recently published in PLOS Computational Biology a cellular automata that is actually trying to artificially create lesions based on cells. So you might find it interesting.
I have to see that. Please send me the. I have to see that.
The gist, it's super hard. It's hard to parallelize it. But I think it's a proof of concept. So you might be interested.
I definitely have to see that.
I'll send it to you. Yeah, or to the chat.
And yeah, and Catherine, I just also wanted to add that explainability. What does it mean for your user? Are you explaining from technical perspective? Are you explaining it for a GP who doesn't understand dermoscopy? Are you explaining for a dermatologist who is trained in dermoscopy? So again, this is the general context. When it comes to implementation, it is just far beyond that engineering explainability for us. Like that's why I think it's really, really important to have different layers of visualization content that is designed for your intended user. And I think this is a difficult thing to do, but it's a really interesting one. And that's when you can tell this help. And I think for CE or other requirements for explainability, it's not just, I totally agree with the panelists here. Like, it's not about the heat map. It's not about like just, showing the technical values of an algorithm or the cutoff threshold. The GP doesn't care about those. They don't even have, we actually looked at some of the visual search modifications that we are making for general dermatology. And it's really interesting. Doctors we are working with, like, even they don't GPs, they don't understand what is like this erythematous or papule or like different dermatology terms. And now you're designing a system that is using all these technical fancy terms for the user who is even like provider, not even patient. So it just gets, it just gets more interesting as you are putting these tools in the hands of your users and evaluating how much they understood. And I think they will rely on the AI system, they will overestimate it. And if they are not communicating or understanding what is provided, I agreed with Philip, specifically if you are going to non-specialists or patients, this can actually result in more errors. But if we speak their language, then that's a different matter. So we are mitigating some of those risks.
Yes. Actually, I completely agree with all of you. And I would spend the entire, for me, evening or night talking about this, because explainability and interpretability, it's something that I care a lot. Unfortunately, I have to pass the torch to Mark to give all these questions, but thank you so much.
We still have a few more questions. So Mark Pombalia is gonna ask the next 3 questions. I'm gonna copy paste them again on the chat box.
So thank you very much. So it is very clear that it is and this question is for Dr. Grana. So it is very clear that the role of classification is very important in our domain, but we have been seeing that segmentation is not so important anymore, or we are not seeing a lot of publications in segmentation. What do you think that is actually the role in segmentation for skin cancer classification?
Well, maybe I can help you gain a lot of time for the next questions, because I think that it's a nice exercise finding the border of the lesion, but the people, so the doctors themselves don't know where the lesion ends, and it's very hard to say it ends here. Okay, so all the idea of segmenting lesion is helpful for a technical point of view, on a technical point of view, but given the new technology, all our effort, at least in my lab, probably we are not as good as other people are, but we managed to get very high results in segmentation scores, so state-of-the-art results, and then plugged in this in a pipeline of classification, and the improvement was non-existent, or probably due to just the variation, as we have seen for the Ghana data augmentation. So my personal opinion is that segmenting, extracting features, and then classifying is not the way to go anymore. And that's just one thing. But I have to say that it may help a lot to provide explainability also. So it tells you something on the ability of your network to understand what it is looking at. But that's just my point.
Can I add something to the discussion?
Yeah.
So I fully agree, probably that binary segmentation, just for the sake of segmentation, is not fully worthwhile doing. But I sat down and actually created or verified segmentation mask for the whole HEN 10,000 data set. And now what you can do when you combine it with a class, you can do semantic segmentation. And so, yes, this is that. It's also called segmentation, but it's kind of a blind spot that we had in our field because the data wasn't there. But as soon as you have a relevant number of cases with the diagnosis and a segmentation mask, you can suddenly do mask RCNN or DeepLab V3 or some what's the newest model. And I think this is something very interesting also in regard to biases, and we try to get a short letter out at this moment. But the data is out there, so you can download the segmentation mask from the internet. So I think this is interesting.
I think that one of the tasks that was dropped or not followed anymore in Isaac was the pattern one, because it was hard, really hard to annotate. We had few data and it was very difficult, but we have a lot of dermatology literature which shows a lot of correlation between patterns and the diagnosis. So why not leveraging that? Because we didn't have the data. So if this is going to be solved, then we have very nice ways of doing that. Well, moving to semantic segmentation will change it a lot. So definitely agree with that.
Dr. Grana, do you think there is a psychological dimension to the detection of the border? I mean, do you think this is related to explainability? I mean, when you find the border, doesn't it make it better for the patient to understand what's happening, or for the inexperienced physician? Or is it all about technical stuff?
Well, I guess that from an explainable point of view, if you are finding a border which is something like, and you cut with a straight line like this, as it happens in some of the annotations on Isaac. Some images have been annotated, well, a little roughly, okay? Or extremely precisely, pixel by pixel annotation, which was clearly not done by a person, in my opinion, at least. So it was looking a lot to like an OXU threshold with some well, manual adjustment of the threshold in some areas. Well, that tells you something on the technical point of view, that we are learning useless things. But if we are able to exactly identify where the lesion is, and you see a regression area which is perfectly identified within the lesion, well, maybe the features which are behind your deep network are able to capture something which is meaningful. Maybe this tells you something from the explainability point of view. So maybe you are looking at the right things. That's probably, and I don't know about the psychological thing, but it helps if you find it correctly. Well, it makes you trust the machine more.
Yeah, thank you. I guess we should move on to the next question.
Yeah, so similarly to segmentation, and now we have seen that it can be connected with explainability, and also I would say that it will be connected also to total body photography. What do you think is the role of image pre-processing for this kind of algorithms that we are exploring today?
Well, I would say that image pre-processing was usually done for helping the algorithms perform better. One thing that now we are doing is applying so many augmentation to trash everything we have on the image and let the network be stronger and don't be fooled by anything which may happen in the image. I believe that there are some pre-processing which are useful, and one which has been a little neglected, in my opinion, is the normalization of images. I believe that in radiology, we have observed a lot of work in order to get extremely precise and information from each voxel. So that we have a scale which tells you the density of the things you're looking at. And these things have been calibrated, and the people which build the machine care about these numbers. And then we look with our machines on the skin, and we don't care if there's light coming from the side, or if the colors are well, absolutely believable, or if your camera has not been calibrated at all. So while some time ago I saw some calibration patterns which have been used in dermoscopy, it's not a common practice. It takes time, and most of the machines are not color calibrated. I think this kind of pre-processing may help. Also, some of the operations which allow you to center crop and consider significant parts may help the final result with the meaning, not just for show. Okay, meaning that you focus on a specific part, disregarding areas which shouldn't be considered, like I don't know, a mark made by the clinician because this looks bad, so we don't want to rely on that information. At least that's what my guess, what I think.
Yep. So to eliminate biases, right?
Well, as much as possible. One thing I want to say about the comment that Professor Schandl did, so finding the boundaries for excising things may be helpful. I don't know, I'm not doing any practice myself, so I don't have a clue really on how you do that thing. But one thing I have discussed with Professor Pelacani, I think some of you know him, is that one thing that we want to know from the machine is if we need to excise or not, more than the final diagnosis. So I think this is a different perspective. So even if we don't get the diagnosis correctly, if we not very good physicians, where the top physicians which know everything about dermoscopy, should we remove this lesion or not? So this would give you an easier task, maybe, which may provide very helpful and less false positives, maybe. Okay, so it's a different take on the annotation that we need to do on these lesions. And of course, this has a lot of bias. If we select only lesions which we are going to excise, then, well, that makes no sense, of course.
I think that one thing that we fail to consider on those models is at which point we are using the model, and I like to think in terms of escalation. So if the model is using, for example, at a general practitioner, we refer the patient to the specialist. So the decision is not really melanoma, not melanoma. The decision is referral. And then if the model is used by the dermatologist, often the decision is again not melanoma, not melanoma. The decision is again, it's an escalation. Are you going to do decision, not decision? So I completely agree with how we could use this model of escalation of health service as a model for the system, instead of diagnosis, action instead of diagnosis.
Yeah, so Emre, should I continue with the questions? Yeah.
Yes, please. I think you have one more question.
Of course. So this question would be for Eduardo Valle. So we have seen that we have different class representations in the data sets. We have a lot of representation generally for benign lesions, and we have a very low representation for some other categories. What do you think that are effective strategies to deal with the class imbalance in the skin lesion classification problem?
Okay, so I'm assuming everybody's doing deep learning, so this would be a given. And the thing is, up to 5-to-1 class imbalance, I think you don't have to do anything, or if you do something, gentle interventions. So maybe change the weighting of the loss function, maybe balancing the batches, rebalancing the batches. Some models prefer one thing, some models prefer the other thing, some models prefer a combination of both. This is a street knowledge, okay? So this is a street knowledge. We haven't evaluated, I don't think we have evaluated formally, systematically, those things. And if you have more than 10-to-1 imbalance, then there are some classical techniques you could try. But in my experience, they don't help very much. So there are surveys about that. It's interesting because there are two recent surveys in the Journal of Big Data. There's a common author in both of the surveys. So Kosh-Govtar is the author of both surveys. It's a survey on deep learning with class imbalance, and a survey on addressing high class imbalance on big data. And the interesting thing is that, again, it makes reference to classical techniques. But again, street knowledge, not systematic evaluation. Above 10-to-1 imbalance, I don't believe those help. So you have this chasm, you have this huge gap, and in one side of the gap, you don't have to do anything because it works. And in the other side of the gap, you don't have to do anything because nothing helps. Just to finish on a positive note, there is this new frontier for deep learning. So things like few-shot learning, zero-shot learning, self-supervised learning, and again, subjective feeling. I think those things are very promising for this kind of problem. Sandra, in her talk, she showed how self-supervised pre-trained has helped on very scarce data. So it's one extreme of very scarce data. And I believe that it's worth trying, for example, the same technique for very imbalanced sets.
Thank you so much. Yeah, completely agree with that. And I'm very happy to see all of these techniques as few-shot learning. They are very interesting, and I think that they can provide a little bit of solution to this kind of problem that we have.
So thank you very much, Mark. Now we have a few more questions that Yuan Liu will ask. Thank you.
Thanks. So the first question is due to Dr. Valley. We know that for skin lesion classification, it generally works reasonably well in distribution data. However, the performance tends to really suffer for out of distribution data. What do you think are some of the effective strategies to deal with this out of distribution issue?
So out of distribution, if you talk about out of distribution, I think that we are talking about for skin lesion, out of distribution for skin lesion, I think we are talking about at least 4 different phenomena. First, diagnoses that are in the test set, which are not on the training set. Second, the issue of cross everything. So cross data set, cross institution, cross device, which was very well illustrated by Harold with the one equipment that has a different color. So cross everything. A third, and very related to the second, we have the issue of spurious correlations being used by the models to learn things. So this is a serious problem. And fourth, and very worrisome, the issue of some demographics not being represented in the data sets. So we have mentioned this several times, the problems, for example, of certain skin colors not being represented in the data set. And I'm stressing this distinction because those different problems require very different solutions. For example, for the problems of diagnosis not being present in the data sets, we have some classical solutions like all literature on anomaly detection or open data sets. But again, I think that there are promising directions in zero-shot learning, especially, or few-shot learning, etc. For the second problem of cross everything, I think that the key word is the literature of domain adaptation. And this is good news because there is a huge literature on domain adaptation for deep learning. And I think that our community is a little behind on the state of the art. So we should take a look at that. But I want to stress something because I loved when Marian showed that in her presentation, and then Constantino talked about that again in his answer, because we often don't consider pre-processing calibration. This is something that we rarely consider, because in our lab tests, in our lab experiments, often calibration is something that doesn't make a difference. But maybe that's an artifact of our experimental designs. And maybe we are not measuring correctly. Maybe it's something that our experiments doesn't show, but clinical practice would show that calibration is very important. And calibration is something that helps in this. Calibration makes the out of distribution in distribution. So for the third problem of the spurious correlation, the keyword is a recent keyword. People are talking about shortcut learning. And this is something that we definitely should pay attention in our community, is all those techniques of how to eliminate this kind of learning. But here, I think that the issue is an issue of awareness. If we are not aware those problems are happening, we are not going to correct them, because when the technique learns spurious correlations, prima facie, they work better. They apparently work better. So if someone is doing a lab experiments and eliminates these spurious correlations, performances go down. So we have to explicitly make designs to showcase the problem of spurious correlations. This is something that Sandra also talked about, the trap sets, when you made the trap sets. So the trap sets are explicitly designed to show the problem of the spurious correlations. And finally, for the problem of representation, I don't think the solutions are technical. So if we want to make our data sets more representative, we have to acquire the data. I don't think there are technical solutions for that. Because even if we solve the problem in the training, we have to prove that they work in tests. We cannot just ask, I don't know, the most vulnerable demographics, okay, trust us. We didn't test for your demographics, but trust us, it will work. So I think that acquire more data is inevitable.
Thanks for your answer here. Very thoughtful. Just want to have some additional thoughts there. What do you think about the problem of like AI safety in general, right? Like, because for example, you know sometimes the model can actually fail, like for this type of auto distribution problems, because the model can never really be perfect. So there could be some sort of mechanism to actually predict when the model could fail, so that instead of surfacing any type of the predictions from the model, you can actually say, oh, we can't really provide you with any guidance there.
So this is another sense. It's a completely different sense of the word calibration, and I think that one exciting development of deep learning is Bayesian deep learning or calibrated deep learning, where the model has a good insight about its own uncertainty, and most models don't have a good insight of their own uncertainty. They make very confident mistakes. They are very confident about their prediction, even when they are very wrong. And it's something that it's also a direction that the community could have, is how to have models that are well calibrated about their uncertainty. This is something that could be very useful.
Thank you, Dr. Reddy. So we're going to proceed with the next question, which is for Dr. Avila. This is sort of a meta question here. What are the challenges you think that are generally faced by the state of art of the skin lesion classification problem? And what are the most promising avenues of research in this topic?
Dr. Avila is not here, I think. She says she was having trouble with her internet. So maybe Dr. Valle from the same group can answer those.
So I'm sorry, can you repeat the question?
I pasted them on the chat.
Okay, the challenge faced for the state-of-the-art skin lesion classifiers. So I think that nowadays, and I know that you don't want to hear that, I wonder if we haven't already extracted all the knowledge we can from the kind of data we have. Because in other areas of computer vision, I think that this is already the case. So we are using state-of-the-art models that are extremely successful in other data sets, and we have reached kind of an upper bound in our community. And so I think that the challenge is data. The challenge is data. So more data, if we have 100,000 images, very diverse images, could we do something? Probably 100,000 images would make a difference. If we had different images, for example, the hyperspectral images, could we do something completely different? Probably. But I don't think that the issue is models. I think that the issue we have, I think that the main issue that we have today is data. I'm very convinced of that. Maybe different data in the sense of different features. I really believe in the hyperspectral thing. Maybe combining data, the idea of using different modalities. But I think that data is the main issue.
That's interesting, Eduardo. I think you said the almost exact same thing 1 year ago, if I remember correctly. I don't think you're wrong. I think so. I think what you're saying is we're not going to be smarter than Kai Ming He. So, I mean, these are super smart guys creating super smart algorithms, we're just applying it to a problem, just. But I don't think it's just hyperspectral. Like, for example, follow-up imaging, I think is gonna become available more commonly in the future. And it's also something that now Scott Menzies has recently published it in the IEEE TMI. They had a small data set, very confined, where they evaluated, I think it was a Siamese network for change versus not change. So I think, yeah, so I think for extracting something out of a single image, we're pretty good. We not just need to be smart about special situations and things. And I don't think just data deserves the name just, because I think creating good data sets is key. I think it's also something Andrew Ng is stressing recently, even more powerfully. Creating data sets is something we need to engage more with.
Creating data is the thing that nobody wants to do, but everyone wants to use. So
maybe as a word for everyone out there. So the HAM 10,000 data set. I mean, I have a university behind me, and I think collecting all the images took decades. And Harold and me, we looked at those 2 years, and I needed also a postdoc fellowship to have free weekends because my girlfriend wasn't there, so we could work it up. It was super hard. But within a single year, it is the most cited paper of my whole career. So maybe that's something for researchers to look out for.
Yeah, but it's interesting. Sandra and I have been working literally for years. We have been working for years attempting to contact, for example, the Brazilian Society of Dermatology, the Brazilian Society of Melanoma, and I'm really, I think that people who can finish a project of data acquisition, they are literally heroes because there are so many obstacles, legal, institutional, organizational. When you finally get to upload the data set to the internet, that means that you are a literal hero because it's really, really not easy. Among the data that I think that would be very exciting to have also, it's time series for the lesion, because time evolution that also could be a game changer in terms of the data that we could explore.
This is going to happen.
Well,
we had a very shameless advertising. We are gonna publish a 20,000 images data set soon, so stay tuned. I will spam you with with the links. Get ready for that because I will send it everybody.
That's very good. I think we're out of time. I think it was a very insightful panel. I'd like to thank all the panelists and all the audience for their good questions and good answers. Now we have the final step of the workshop, which is closing remarks, and Katerina Barata will do the honors, please.
Do I have permission to share my screen?
Yeah, let me do that.
Let me just.
Yeah, I think you should be able to do that now.
Okay, thank you.
Yeah.
So we are reaching the end of the 6th ISEC skin image analysis workshop at CVPR. Unfortunately, as last year, this turned out to be a virtual event. Although we planned for all 3 scenarios, physical, hybrid, and virtual, this was the one that stayed. And on behalf of all organizers, I would like to thank you so much for your participation on this virtual event. First of all, to the keynote speakers, Dr. Avila, Dr. Sadeghi, and Dr. Kiesler for their very insightful presentations, for sharing with us your vision, your contributions, your ideas towards the future. Thank you so much. To all the paper presenters and authors, to the panel members, I'm so happy with this panel, you can't imagine. So last year, this panel popped up more or less naturally, and seeing that in almost 1.5 hours, we discussed so much, we talked so much, is so good. I'm really happy. To all the attendants of the workshop, thank you for supporting the event. And finally, to our sponsors, so Canfield and Google. And the next step will be to announce the workshop paper awards. As Emery mentioned in the beginning, we have 2 awards. The first one is the Honorable Mention Award. And let me tell you that the winners of these awards, both of them were selected not only based on the reviews that we received for the committee, but also on the potential impact of their works. And having this said, the Honorable Mention Award goes to the paper Evaluating Deep Neural Networks Trained on Clinical Images in Dermatology with the Fitzpatrick 70K dataset, which we believe will bring some disruptive things to this field with this idea of different skin tones. And congratulations for this award. And the best paper award goes to Dilemma, Deep Learning Ensembles for Multiple Annotation Application to Skin Lesion Segmentation by Zara, Kumar, Saeed, and Gassam. So congratulations for these awards. And what are we going to do next with ISEC? So we have a couple of events in the next couple of months. The first one is our JBHI special issue. So as Emre mentioned in the beginning, we had a special issue on medical image analysis that ended up receiving more than 70 submissions. And now we have a second special issue called Skin Image Analysis in the Age of Deep Learning. Submissions are currently open and the deadline will be September 1st. So we will invite you all to submit your works to this special issue to support it. If you have all submitted to the workshop and your paper was accepted, please consider extending your work and submitting to the special issue as well. You still have time. And we plan to have this wrapped up at the beginning of 2022. Let's see how this goes.
I would say that as almost in all special issues, don't believe those submissions.
Yeah, don't believe these dates.
So we're almost confident at this point, even 3 months ahead, it'll be shifted to probably November or something.
Yeah, so the medical image analysis was pushed 1 or 2 months, and this one will probably as well. Please notice that this one is called In the Age of Deep Learning, so this one is more focused on the deep learning methods, while the previous one was broader in terms of applications. The second event, it's the usual ISEC challenge, and I think that this will make all of you very happy because you have been talking about time series and having this idea of longitudinal data, and I'm very happy to tell you that the next challenge will take this into account. So the idea will be to diagnose melanomas based on time series of fusions. The data set is currently being collected, so expect the challenge to be released, the training sets, between the end of 2021 and the beginning of 2022. And it will probably be hosted together with Kaggle as last year's challenge. And based on all of your comments, I believe that you'll be very happy with this announcement. Finally, and this brings me to the final remarks. What I see from this workshop, and not only from the workshop, but also from the special issues and the submissions that we have been receiving, is that we have come a long way. So since 2016 that our data sets have been increasing, we have been working with more and more complex models. And actually we are tackling scientific problems that we haven't thought in like 5 or 6 years ago. So like we saw, we were segmentation, feature extraction, classification. Now we are concerned with class imbalance, without the idea of out of distribution, how to handle unknown classes. So the future is promising in terms of problems and what we can solve. And I believe that we are also moving in the direction of new kinds of data. So clinical images are becoming more important. Total body photography wasn't something that we thought like 5 or 6 years ago as much as we are doing now, even pathology images. So this will be really interesting in the next couple of years, I believe. Another thing that I'm really happy to see is the number of researchers working on this topic that has been increasing and increasing and increasing, and it's very good to see some new faces at the workshop, as well as some old faces that we have become used to seeing and supporting our workshop. And what this allows me to conclude is that ISEQ is advancing not only melanoma research, but also the research on other skin diseases. So people are becoming aware of inflammatory diseases, psoriasis, so on. So this is a very good job from ISEQ side. And for this to keep going, actually, we need your help. So we need you to support ISEQ, to use the data from the archive. When you use your data, please try to release it. Try to release your code for things to be reproducible, such that everyone can benefit from your work. Keep contributing to our events, to the workshop, to the challenges. And if you have any suggestion, please don't be shy. Send us an email with suggestions for next year's workshop, because obviously we hope to see you all on the 7th ISEQ workshop in 2022. And let's cross fingers for a physical event instead of a virtual one.
Thank you very much, Katerina.
Thank you all.
That concludes our workshop. Thank you again for attending, sharing your ideas. Have a nice rest of your CVPR.
Mm-hmm.
Thank you.
Thank you, everyone.
Thank you.
Thank you, everyone.
Bye.